Very good evening to one and all the students connected from all over the country and from IERS. For everybody, very good evening. Today's lecture will be on National Urban Information System and Bhuvan NUIS. This is one of the good high resolution mapping exercise carried out for urban areas. So that's why we wanted to share regarding this whole project, how it started and what was the objective of that, what is the methodology for that, what is the scale of mapping, data used and expected results. And after doing that, how it can be, the whole data was hosted on the website for viewing and how it can be used in the Bhuvan news. That is the overall content. Okay, coming to the background of this, this is a project taken up by Ministry of Urban Development, Government of India, launched under National Urban, launched as National Urban Information System under the aegis of NNRMS of Department of Space. The basic rationale behind this being the Indian urban environment is undergoing a radical change. Basic idea with which this project was started. So we do have maps available from mapping agencies at 1:50,000 scale, 25,000 scale, and for some cities we do have maps, guide maps available at 15,000, 20,000, that is it. But considering the fast development taking place and it is realized, it is recognized that urbanization is very important for the development of the country, we need higher resolution, higher scale maps for the urban area. With that in mind, this project was started. Okay, as I told, this project is conceived for mapping thematic assets on a scale of 1:10,000 for the city and the surrounding area to assist in preparation of the perspective master plans, or also called as development plan for the future development. That is the basic idea. So urbanization is very much important, but at the same time we should have the planned development. Unplanned development leads to a lot of problems, which it can be avoided provided we have a good development plan at a good scale prepared. So with this in mind, high resolution satellite data of Cartosat-1, that is a 2.5 meter panchromatic data, and ResourceSat-1, that is a LIS4 data, coupled with good ground and collateral data congregated by NRSC and ISRO with the active participation of the partner institution in the country. Being the towns are spread all over the country, the towns and cities. So that's why it was done as with a lot of partner institutions. So with that in mind, the whole project was developed by NRSC and Ministry of Urban Development, that is Town and Country Planning Organization. Okay, so I wish to just show you one slide. We'll not go more detail into the number of towns and cities. Basically, if you see that in 2001, we do had 5,161 towns, which has grown to 7,935. And big jump is there in the census towns. Also growth is there in statutory towns, then urban agglomerations and outgrowths, all this. So basically, because towns are growing very fast and some cities and towns are growing much faster, so there is a very much need to use the high resolution satellite data and the geospatial technology to prepare the development plans. That is the basic idea for which it has conceived. Okay, just before going into it, we do get some terms like perspective planning, development planning and project planning, some terms like this in the subsequent slides. So just before going that, I wish to clarify this, what we do exactly mean by it. So regional planning means it is a macro level planning, and also it is a very long term planning covering a state or a cluster of states, basically for the spatio-economic development of the region. So we will not be looking more into the regional planning in this thing, but it's more into the perspective planning and development planning and the zonal level planning. So what is the perspective plan? It is a macro level and a long-term planning exercise to address the policy issues related to the spatio-economic development of the district or a cluster of districts, framework for further detailing and guidance for preparation of the master development plan. So we'll be looking into this point, how what is the input required for a master development plan and how we can get this information from the geospatial tools and the high resolution spatial data available. Also, we'll be slightly going into the development planning. That is nothing but a block level or a meso level thing. Within the framework, of the approved perspective plan of the media, and it is of medium duration. So the development plan will be, the details will be taken up from the perspective plan. And the next one comes the project planning. So that is a micro level planning, and it is a detailed annual work layout for executing by an executing agency and prepared within the framework of the development plan. So the projects planning will be under the framework of the development planning under the framework of the perspective planning. So these areas will be covered, and how we can use this data, the high resolution satellite data and information, ancillary information for this. That is the whole idea behind this project. Okay, as I told you, this was covered for 152 towns, which were there. Some metros were there for class 1, class 2, class 3, 4, 5, 6. So all the towns were covered in different states. How they have selected, it depends on the state to decide which towns they have to take up. Likewise, many states have decided the towns which will come under this NUIS project. So this is the overall distribution of the towns in the whole country under the first NUIS phase 1. Okay, coming to this, what are the objectives of this NUIS? So the first one will be to develop attribute and spatial information base for various urban planning levels. So for various urban planning levels means the perspective planning, the zonal planning, the detailed level planning, all the exercises for which we need to have develop the attribute and spatial information. That is one thing. Use modern data sources like satellite and aerial platforms. That is the other thing, to develop the spatial and attribute information. Also to develop the standards, what is there regarding the database, methodology, equipment, software, data exchange format, etc. And finally, this will be used for to develop urban indices to measure and monitor the health of towns and cities. Also to build capacity in the use of remote sensing and GIS among the town planners and the town planning professionals. Also to develop a decision support system for various planning levels. So these are the overall objectives of this project, that is the National Urban Information System. So basically it contains two components. The first component is called Urban Spatial Information System. So basically what we are trying to do, we are going to have a seamless integration of databases in two scales. That is, one is at a 10,000 scale, which is using the high resolution satellite data, that is a COTOSAT1 plus LIS4 merged data. Also 1:2000 aerial photography data was used for very high dense areas, and also the same data was used for utility mapping at 1:1000 scale. So this is for the central area, very high dense development area. This 2000 scale aerial photography was done, and for the whole town it is at 1:10,000, and for some pockets at 1:1000 scale utility mapping was done. Also there is a the National Urban Database, Urban Data Bank and Indicators data was being collected on a periodic basis. That also will be used with USIS, that is Urban Spatial Information System. So in this one, the components include the hardware and software, the base map and GIS data on 1:10,000 scale, 2000 scale, and utility mapping on 1:1000 scale, 1:1000 scale, with the capacity building and application development. All these things becomes the components of this. So just to say how this whole concept will come, it is like we are going to use the satellite data, aerial data, ground data and methods. The satellite data, as I told you, we are using the COTOSAT1 and LIS4 data, the aerial data, the ground data means field data. And all these things will be used to generate the geospatial attribute data and analysis. This is the second step, and it will be followed to develop and implement information system at different levels. That means perspective plan, zonal plans, detailed planning, and all these things come. And finally, to build a decision support system, training and infrastructure. That is not the end. It has to be continuously, the database has to be updated. So again, periodically it will be updated, the data. So that is the overall concept of the NUIS. Coming to this, in the as I told you, in the GIS database organization, we are going to, it is planned to use the high resolution multispectral stereo images, the satellite images, that is mono data and stereo data also for the COTOSAT1 for 1:10,000 scale mapping, aerial photographs, also ground survey, total station for towns with small area for 1:2000 scale mapping for the core area of the towns and cities. GPR data will be used for the GPR will form the base for mapping of underground utilities. So the GPR survey will be carried out in selected towns in the core areas, and the utilities map will be on the scale of 1:1000. So GIS will form the core of the NUIS scheme and will be used to prepare the digital database. The GIS techniques will be used to develop the customized packages to generate the outputs required for urban planning and management. We'll just see that what type of outputs will be generated. Also, the ground control points library will be used for the geometric corrections of the images. So all these things will become the part of the GIS database organization. See, the basic idea is what I'm trying to tell regarding how the whole project was conceived and how at what scales and the overall standards adopted. I will be just covering the details. Okay, as I told, this is this overall methodology. We do have this satellite images at 1:10,000 scale. So we do have the aerial photographs on 1:2000 scale. This will be corrected using the registered ground control points. Finally, you will get 1:2000, 1:10,000 scale maps, followed by ground penetrating radar, that is a 1000 scale maps. This will be used for the water supply and sewerage maps. Also the attribute data generated and compiled by urban local bodies, that is the NUDBI data for the 152 towns will be used. All these things will finally come and it will be used as the application development using the GIS and RDBMS software packages. Finally, it will be used for the master plan or the development plan, we call it, the zonal development plan, the utility development plan, and also to the urban governance. So that is the basic idea for the master plan, zonal development plan, utility development plan, and urban governance. So the whole data will be used for this. And because the whole project is being carried out by different partner institutions spread all over the country, some standards has to be designed because finally the data has to be seamlessly integrated. So here NUIS design standards comes into the picture. So why we require standards? Standards are important elements of the NUIS scheme and are of direct relevance to the database standardization, which makes applications and technology work together. So standards encourage the effectiveness and efficiency, also helps to reduce the cost, protect the investments in data against technological change, increased availability once it will be more accurate, complete, and current data. All these things leads to the data and the related activities can be considered at the conceptual, logical, and physical levels, and standards may be needed to identify the volume of the data, parameters required for the urban planning, frequency of the updating, level of redundancy, level of compilation, nature of processing at different hierarchical levels of urban planning. All these things becomes part of it. So to identify the volume of data and parameters required for the urban planning, okay, this is the same thing. And to finally to design a comprehensive urban information system useful to meet the needs of various hierarchical levels, that is the perspective plan or development plan, or the zonal, or we also call it town planning scheme exercise. So all these things will be used for this applications. So what we are going to get from this? So the USIS, that's Urban Spatial Information System, that is the spatial data for the master plan at 1:10,000 scale. From the remote sensing images and the topo sheets, we are going to derive so much of information, which includes land use, land cover, physiography, DEM, geomorphology, geological structures, lithology, drainage, soil, surface water bodies, roads, rails, canals, transportation nodes, slopes, and geomorphology for the city area. All these things will become part of the information derived from remote sensing images. Also the topo sheets will be useful for this. And some incorporated data also has to be obtained, which includes the lithology, soils from other departments, location of the heritage sites, location of the slums, squatters, city planning zones or the ward maps, village revenue maps, cadastral maps, polluting industries facilities, earthquake or epicenter data, flooding data, land values, soil depth, texture, location of the major utilities. So these are the incorporated maps that has to be obtained in addition to the remote sensing and the topo sheets. This is all the things which will become. So finally, all the things will be used for deriving maps from the NUIS applications, which include, it can be for land use change studies, urban suitability, environmental sensitivity, hazard zonation, air pollution, water pollution, tourism development. So all these things becomes the applications for which you can use this database. Tourism development, transportation plans, industrial plans, population trend studies, planning scenarios, groundwater prospects, slow road buffer zones, railway buffer zones, water bodies and watershed buffer zones. So all these things becomes part of it. Also, the development attributes obtained from urban local bodies include the regional setting, demography, socio-economic development, industry, all this list. So when the database is made so comprehensive, which includes the data from the remote sensing, topo sheets, ancillary information, field data, all these things will be used to this. Also, I told you for core areas at 1:2000 scale also was planned, but as 1:10,000 doesn't serve the purpose. So that is done from the aerial photographs, which includes the point, line, polygon information, the city planning zones, ward maps, then urban land use land cover, then land use change, zonal plans. This includes from the spatial as well as the derived maps. The attributes includes a big list, which can be development attributes on what basis obtained from city administration, then development control regulation, authorization, approval records, land requirement, available infrastructure, land ownership, compensation. So the amount of detail keeps changing. Past land pooling schemes, urban cadastre, all these things becomes more detail keeps coming at 1:2000 scale. Then also the value of it, plot number details, also it can be used for the net demand, development cost, development details of acquisition property, zoning regulations. So there are a lot of applications once you go at 1:2000 scale. So at 1:1000 scale for the utility mapping where GPR, that is a ground penetrating radar, will be used. From the aerial data, the urban layers of point information, the line features, polygon features will be derived, and maps derived from GPR will be for the waters network, sewerage network. Also the attributes has to be collected from the urban local bodies regarding this. So that is regarding the GPR thing at 1:1000 scale. Okay, just coming to, no need to go into very much detail. I'll just cover some points which are of importance, but the basic idea is we wanted to just highlight the overall, the way the project was developed by NRSC with TCPO, and that is the Ministry of Urban Development. So in the design standards, we do have something for the image standards for the images, which includes the LIS4 data, that is a 5.8 multispectral data, 2.5 meter pan data, and it will be used in the UTM projection, and the datum will be WGS84. And what is the positional accuracy for this one? For the satellite data, it is around 5 meters. For this 1:2000 scale, the resolution will be 20 centimeter aerial data, that is the aerial black and white data, again at UTM projection, WGS84. Like this, lot of detail, even band-to-band registration, what should be the accuracy. All these things keep coming in image standards. Coming to the thematic mapping standards. So we'll be making a lot of thematic maps. What is the minimum mappable unit which was considered at 1:10,000 scale. So it is like 3 mm by 3 mm is the minimum mappable unit considered. Maybe in the subsequent lecture on urban land use land cover system, maybe you will be covered more in detail regarding the minimum mappable unit. So 3 mm on 1:10,000 scale comes to 30 meters. So 30 into 30 means 900 square meter. So at 1:10,000 scale, we are taking a smallest, that is the smallest minimum mappable unit is 900 square meters, the smallest unit we have considered for this project. Less than 900 square meters, it has been not considered at 1:10,000 scale. So but when you go to the aerial photography, it becomes 1 millimeter by 1 millimeter. So overall, this is an important point which needs to be considered at what is the minimum mappable unit at 1:10,000 scale, at 1:2000 scale information. This becomes part of the thematic mapping standards. Then comes GIS database standards. So what we will be considering, datum, precision, minimum frame size for NPR. So all this information keeps coming here in the GIS database standards, followed by output standards. Here in the output standards, the output format, how it is going to be used in GeoTIFF, shapefile, JPEG, And so different formats, how it will be used, what will be the output framework. So a lot of information, and the output projection will be UTM projection, output data will be WGS84, all this. So for this project, all the standards has been worked out, and it has followed for the whole, all towns and cities of the country, that is 152 towns which has been taken up. Next comes the thematic accuracy standards, what should be there. So this is the big list of the thematic accuracy standards. So just it is nothing like to make more complicated. What we wish to highlight is when a project is being taken up for the whole country, standards has to be worked out in detail to avoid problems at a later stage. That's why the whole thing has been given. At the end, I will try to show you the document from where we have taken up all these things, and that is available online also. If somebody wants to have more information, I request you, just you need to look into those. If you can see that manuals, all the information regarding this has been given in more detail. Then I told you there is a framework. Again, it is done as per the Survey of India NUIS open series maps. So if you see the whole country like this is at 1 degree, this is at the 1 degree, this is at 15 minutes, at 1:50,000 scale, this is at 1:25,000 scale, this is at 1:10,000 scale, this is at 1:2,000 scale, followed by 1:1000 scale. So this is GPR thing has been done at 1:1000, aerial photography thing has been done at 1:2000, 1:10,000 satellite data. So the whole idea is to work in a hierarchy, the requirement of the hierarchical planning that includes the zonal level plans, the development plan, whole thing, and again it can be even integrated at the regional level also. That is the basic idea with which the whole thing has been worked out. And there is a land cover classification system which has been decided for 1:10,000 scale. So basically, what if you see, this is the NUIS, the map features and the coding scheme. The coding scheme for every input element has been worked out, keeping in view the planning hierarchy as well as the natural hierarchy within the feature class for each of the theme. All the data elements were given a unique name, which is self-explanatory with short form. If you see this, in the land use land cover classification, we do have up to level 1, 2, 3, 4, 5 classifications. If you see for everything, there is a code given. For example, built up is there, built up, it can be built up in level 1, built up. In level 2, it will go to built up urban, built up rural, it can be commercial, industrial, like this it will be coming. And even the built up urban can go to residential, and the residential can go to high density, medium density, low density. Like this here, if it comes to high density, high rise apartments, low rise, medium density, like this, all these things will keep coming. So basically in this project up to level 3, the 1:10,000 scale satellite data has been used, that is the panchromatic plus list 4 data has been used. The list level 4 and 5, even the aerial photography information and field information has been used. So the same thing if I show you in detail. So this is the built up urban, it will built up in level 1, will go to built up urban. In level 2, built up urban will go to residential, industrial, commercial, like this. In level 3, followed by the residential can be with the high density residential, medium density, low density, then different type of industries. So like this, the classification becomes more detailed. So basically up to level 3, satellite data has been used, 4 and 5, the aerial photography information has been used. And okay, this is the same thing for the utility mapping. What type of attributes has to be collected? This is the same thing what has been done, shown earlier. And what type of information will be there? Here, if you go for the utilities, it can be like walls, sluice walls, core walls, booster pumps, reservoirs, T junctions, meters, public taps, like this sort of information will be coming, but everything will be, there will be a code associated for each of these features. That's the basic thing which will come up with each feature. Okay, just this is regarding the theoretical part. I will just try to show you some deliverables for the thematic mapping. We were involved for mapping of some towns of Himachal Pradesh, which include Nahan. It's a small town, which we will try to show you how the outputs will be coming. Okay, this is the panchromatic plus list 4 image, that's a merged data. The yellow line, what you are trying to see is the boundary of the town for which mapping has been thought of, and the boundary has been decided by the urban local body. This is what you are going to see this. You will be seeing some water bodies here. And it's a very small town in Himachal, and it's a district headquarters, and sometime back in the population was 26,000. I wish to tell that it's a small town. Okay, the same earlier slide I have shown you that some water bodies which are small, but because it's a panchromatic image of a 2.5 meter data, you'll be able to see that water bodies. You can see 1, 2, 3. These are the water bodies, small water bodies which are there. So you will be able to see more detail once you. But this is not at 1:10,000 scale. We try to fix the whole image to the screen. That's why we have not mentioned the scale here. But if you see it at 10,000 scale, you will be able to see more detail at a building level also. This is a list 4 now. So if you compare with your earlier slides, because it is 6 meter data, you will not be able to see more detail, but you do have the color information available. But in the panchromatic image, it has the more spatial resolutions, but color information will not be there. So data merging techniques like Brovie method was used for the data merging here, because it's a visual interpretation based analysis, thematic mapping exercise. So Brovie method was used. This is nothing but the data fusion being used. Okay, these are the different layers which were generated, which include some primary layers. As I told you, it is urban land use land cover, the physiography, the geomorphology, the geology, lithology. So this component, that geomorphology, geology, lithology, this is from the geology experts will be working to generate this thematic maps of the related to the geology, geological structures, and lithology. Soil experts will be working on to the soil maps, the drainage, so the surface bodies, roads, rail, canal, transportation network, all these things come into the primary layers. And in the administrative layers, which it can include is the administrative boundaries, which can be district boundaries, some state boundary, the ward boundaries, on city boundaries, town boundaries, settlement, village locations, all, and even the forest boundary. So all these things becomes part of this, the incorporated layers. So this is how the whole thing, as you've seen this is the town thing, these are the drainage features, and this is the legend, what it has been given here. So it can be a non-perennial or a perennial thing. So more details of all these layers has been given in that manual. If you wish to have more detail of this classification system, how it has been worked out, you need to refer to that manual for more details. So this is for the land use, and as I told you, for using the satellite data, we are going up to level 3. So this is the whole classification system. This is how the whole land use maps look at 1:10,000 scale. Then the same, the land use and the base map features also has been overlaid. So once it is a GS thing, the whole thing you can keep overlaying. So we try to overlay the base layer features onto the land use map, and the roads has been overlaid on the satellite data. All these exercises can be taken up in GIS easily. So this is regarding the geomorphology and structures information, faults, lineament, fractures, and all these things. All the information interpreted by geological experts regarding the geological geomorphology and structures. This is regarding the lithology, and the classification has been given here. This is for the physiography. So these are all the themes which are generated using the satellite data. So this is regarding the soil thing, and the soil, this is basically done by the soil experts. The yellow dots, what you are seeing here is the soil profile information. So they try to take some soil profiles at what is the type of, what is the soil depth, what is the soil texture. So a lot of field exercise in the field, they try to collect all the data. So if you see, this is the soil map. There is a different type of soils, black soil. So different type of soils available. These are the samples at which the points has been collected in that particular town. This is the soil texture map. What is the type of texture, clay. So different type of classification for the soil texture thing has been taken up. So this is nothing but the depth information. So the basic idea is, if you want to the agricultural productive area, if you want to preserve it for the future generations, basically the soil depth information and soil fertility, soil texture information also will be useful, and finally it can be used into the development plan. Yeah, this is the classification of the soil categorization. So you will see red soil, black soil, mixed red, black soil. lateritic and alluvial soil. There are different big classifications. This is the depth, this is the soil texture. Finally, when you see a code like this, RTT11D04, R means it's a red soil, RD means it's a red soil, then T11 means clayey, and D04, it means deep soil. If you see D4, it's a deep soil, means 100 to 150 centimeter depth. Basically, this is the information provided by the soil experts. So in addition, every point wherever they collect the field information also with this. So every point, whenever you click that, you will try to see the photographs of that at particular in the field also. These are the some of the land use information. Okay, after generating all these things, the whole data has been hosted on Bhuvan. That's what we wanted to show you on this, but we will not be going into the Bhuvan services because already it has been covered. I wish to show you where this data has been hosted. That is the basic idea to show you this. So this is the Bhuvan thing. So once you go into to the Bhuvan site, you can see here for the urban land, if you go for the selected theme, you have to select that urban land use at 1:10,000 scale for the NUIS. Once you select here, you have to select the state. Here we can select that particular state. So as the town which I have shown some time back, the Nahan thing, the same data has been hosted on the Bhuvan servers. So once the data is finalized, the data has been hosted on the Bhuvan servers. This is the whole land use, land cover classification, which I have shown you earlier. This is the same thing, the same land use map. You can zoom in and zoom out and all these things you'll be able to do using the WebGIS. So the same thing, the buildings 2.5D buildings also you will be able to see for bigger buildings like this. Not only that, the whole 150 two towns information is hosted on the Bhuvan. So I have shown you the Nahan like this. This is the Chandigarh thing. So if you select the Chandigarh, this is the map of the Chandigarh. So this is the land use, land cover classification like this. All the information is available on the Bhuvan NRSC website. So basically, finally, after doing this, this is just the hosting of the data, and finally the plan is to how to use all the data to prepare the master plan. That is the basic idea with which it has been taken up. So how the Bhuvan Geo portal can be used for the planning, that's what the idea is. So what is Bhuvan? Bhuvan is a geo portal of the ISRO, for which the Indian Earth Observation Data Products and Service for the Indian Earth Observation Data Products and Services. Bhuvan provides interpreted satellite images with thematic data and other services to all, apart from base for the urban and regional planning for the authorized government agencies. And some of the salient features are provides access to the Bhuvan GIS databases as well as any other relevant information from other websites also. So that incorporated layers, it will be available to overlay that and use it for the master plan exercises. So this basically helps in avoiding the duplication and redundancy. Okay, and the respective ULB means urban local bodies can upload the town specific spatial data like cadastral maps and attribute data to the Bhuvan, and comprehensive database required can be organized and used for the formulation of the master plans. And here open source freely available WebGIS software packages. Here QGIS has been used. Also, you can use the WMS services for the data creation. Okay, this is the Bhuvan NUIS basic workflow. Basically, first we need to have the authentication, that is username and password. Then you can download the software of the QGIS, and there is a plugin which is specially created for this. Once you install it, you can access and view your data. Then you can create your data. Also, you can upload this data to the Bhuvan, and once it is approved, the uploaded data, even it can be viewed by the public. So that is the basic workflow of the Bhuvan NUIS thing. So, and this thing, it can be worked isolated, see the database creation before uploading, you can do it as a standalone thing. Once it is done, you can just connect to host the data onto the Bhuvan NUIS. So what we have seen sometime back, the Nahan, Chandigarh data and all these things is, so once it has been approved, it has been put onto the Bhuvan NUIS as a public, we are trying to view the data. That is the basic thing which has been shown in the earlier slides. Okay, this is just a screenshot of the QGIS, how it looks like, and followed by there is a small plugin which was created for the Bhuvan NUIS, which needs authentication. For different type of authentication is there for people who create the data. They need a different type of authentication, who will approve and who can view at a higher levels. So different type of authentication will be needed. So that is what it is being shown. In subsequent slide, I will be able to show you something more. Okay, this is what I was trying to tell you, that Bhuvan portal, there are three hierarchy levels which was created. One is for viewing, and one is for the data creation, and one is for the feedback on the uploaded plans. So after the planning activity is over, such data can be uploaded onto the Bhuvan portal for public viewing. As I shown you here earlier, that Nahan, Chandigarh, all these things. So after the mapping exercise has been carried out, it can be uploaded. It was uploaded onto the Bhuvan portal, and we just try to show you the same screenshot information. All these things, people who can create the data, that is the Bhuvan access town planning, town level, urban planning authorities can create, edit, and even upload the data to the portal after permission. So that is what the people who can create the data. After approval, they will host the data. Once it is hosted, people can view the data. And even there can be citizens, government departments, and Bhuvan access town plan, town level urban development authorities can give the feedback also. So basically, in the master plan exercise, once the plan is prepared, it will be uploaded on the website for public objections. So this can be a good mechanism. Once the data has been hosted, people can view the data, and even they can give their feedback, that is for the public objection information. So the basic, earlier people used to display their data and their maps in their offices of the town planning department. People has to physically go there, see that. In addition to that, these days you can host the data onto the servers like Bhuvan, so that people can view the data and they can give the feedback of the uploaded plans. Next thing comes available information hierarchy to a draftsman or a junior engineer. They are the people who prepare the data, and it has to be approved by the town planning officer before it is being hosted onto the website. So, and even the commissioner level officers also can have the view the data. So each level has different powers to access the Bhuvan database and can be customized as per the urban local body procedures or methods being followed. So the beauty of this is you have the customization option available as per the method followed by the local bodies. Accordingly, it can be implemented in the same mechanism. So what are the three levels which I was trying to tell you? The junior engineer or the draftsman can work on the town database and have the rights to read and control the data in the portal database. Draftsmen have access control for all database for ready, edit, process, and write to a temporary folder. At this level, personnel can create new spatial files or edit the existing files and upload the data for approval. So initially the people, the JE or the draftsman creates the data and they will send it for the approval. So the town planning officer can work on the town database and have the rights to read as well as the write on the database. Town planning officer has full control on the database. The maps, analysis on the existing data, uploaded data and reports by draftsman are posted in temporary folder and requires TPO, that is town planning approval, before to move these files to the database. So he has to approve and finally it will move to the database, and before that it will be in a temporary folder. And what a commissioner at a local body can do, can work on town database and has the rights to self-controlled read and write access for that particular town only. The commissioner of the local body has read and write access for his town data. And also the state level authorities, for example, Himachal Pradesh. So Himachal Pradesh State Director Office of State and Town and Country Planning Department have rights for accessing the respective towns respective state towns. So all towns of Himachal Pradesh, the directorate people can view it, but the commissioner can only view the specific town information. Then the town planning officer, as I told you, he has the read and write capability for this data for his town. And at the national level, the Ministry of Urban Development, TCPO Delhi, have the rights for accessing state-wise all towns. In fact, all towns of the country they can track. So overall, I wish to try to tell you this is a hierarchy level. At a country level, the Ministry of Urban Development, TCPO, has the right to access all state, all towns information of the country. State level Directorate of Town Planning, they have access to towns of their state only, commissioner to their local body, town planning officer, approving authority for his town only. So the beauty of this is that it can work at a hierarchical level. Next, that's not the end. Then that is shown on the web-based thing, Bhuvan NUIS. It can be even brought into the mobile application also. So Bhuvan provides variety of solutions on a mobile platform also, in addition to the field data collection and upload, which can be used for the urban and regional planning exercise. There is an application called Bhuvan APK, which can be downloaded on compatible mobile softwares. Both attribute data and pictorial data can be collected from the field through the APK and uploaded on Bhuvan to develop a centralized database, and thereafter can be viewed for all for the decision making. You must have seen the Manu example where the students who have collected all the information has been uploaded onto the service. Other applications are also available as part of the mobile APK, such as the emergency services responses at the event of an hazard. Such applications can be used for smart city concepts and can be modified or customized as per the need of the urban local bodies or the development agency. So this is not the end, even it can be customized as per the procedure followed by the local bodies. Administrative boundaries and ancillary data will be there. So NUIS Bhuvan web app, it shows the status, what is the status updation, when it has been updated, what is the data versioning, whether proper logging is there, feedback is there, all these things you can be able to view. Also the citizen view, it gives an overview, overlay of the master plan, overlay of the vector layers, time series visualization, feedback, all these things information will be available. So at a town specific view, you do have the authentication system, you do have junior level thing for the creating and uploading. This is for this second level town planning officer who can approve this, and the higher order the commissioner thing for the visualization, also the state level, national level. So these are the different type of hierarchical view to the applications which can be used. So basically what is happening is there is a GIS server, we are using the internet thing. So for the GIS mapping, for the GIS web thing, so you can use the web services and also you can upload your layers. So it can be used by a lot of internet users. So finally, in the software tools, it can be used for creating and updating the Bhuvan NUIS. It can be a single point data management at a client or at a Bhuvan server thing. Then Bhuvan data servers update or existing the GIS data, create new GIS data, linking the attributes to the GIS, mobile applications for the field data. Finally, the data uplink to the Bhuvan. Then you can serve the uploaded data as WMS services also. Then single point data management, it can be done. There is a help module for the plugin, video lectures are available. So basically it has given a lot of experience at a high resolution, using the high resolution mapping. Also it can be adopted for the future urban programs. So this is the thing which I was trying to tell you. There was one thing called National Urban Information Systems Design and Standards, prepared by Town and Country Planning Organization in association with National Remote Sensing Center. So this document is available on MOUD website also. So most of the designs and standards, all the designs and standards which I have shown you in the slides, I have taken from this manual only. Also, there is another manual called the Manual for Thematic Mapping using high resolution satellite data and geospatial techniques. So this is a very good document where you have the information, all the features, the land use land cover system, which was followed for 1:10,000 scale at different levels, level 1, 2, 3, that 4, 5. What does residential mean at 1:2 at level 2? What does it mean at level 3, level 4, level 5? All the details has been given, a pictorial thing. Also what type of accuracies, regarding the accuracies, all the information has been mentioned here. So if you wish to have more information, you just see the, go to the website of MOUD, TCPO or NRSC to find out these manuals are available for your future reference.